Hello everybody, how are you doing? Please let me know if you can hear me, if you can see me. And yeah, I guess we should be good to go. Today I decided to start a little bit earlier than usual, so it's only half an hour earlier. But yeah, I hope we'll be able to do some things today. Hope you're fine. Good. Okay, thank you very much, Murad, for confirming that everything is okay. I just received your message. So once again, no matter if you're watching this on Twitch or if you're watching this on YouTube, just don't be shy and get engaged, come up with ideas. I really like to have this sense of community when I do this kind of streams. That's important to me. Good. So let's see exactly where we did last time. So we were struggling, or I was struggling, but that's also a conclusion for me that well, when I'm doing this late late in the evening or at night, I'm not thinking straight, because the problems that we faced the last time when we just finished is that what we wanted to do is actually create a migration with the information that we have so far. And the problem is that once again, I'm not sure. Did you watch my last stream? It would be nice to know if you did watch my live stream, the last one, 2 days ago. So please let me know. That would be important because, well, I would need to know or to define how deep I should go with the summary of what we did last time, actually. So the main idea was, or the main problem was that we have this idea of having a user object which actually extends the identity user, because we have implemented also ASP.NET Core Identity with our Blazor app. And I want to keep all the information from the identity user, but I want to be able to add my own information to it. And I want in this application to keep this distinction between the user as a boundary of identity management and a profile or a user of the application itself. And that's why I have created this user, which actually, as said, inherits this identity user class, which comes from Microsoft ASP.NET Core Identity. But for instance, for the regular users, I would have profiles. Now, this class athlete is actually a profile, and I have created a user interface for that to define all the properties that are kind of like, I would say, common for all the different user profiles. And the reason behind this is that I can imagine that in this application, we'll actually have different user profiles. I could have regular users that would be able to create workouts to track their progress and things like that. And then there would be also trainers. And trainers would, for instance, be able to, well, connect to different athletes and to train them and create maybe workout plans for them, training plans, and follow their progress and things like that. So this is why I want to keep this distinction between the user as a boundary of identity management and the profile itself, because theoretically a user could be both an athlete and a trainer in the application. So he should be able, or he or she should be able to easily change the profile. For instance, if the user wants to access the application at a certain point as a regular user, he should be able to do that. But if he just wants to switch and use that application as a trainer, it should be as easy as just, well, switching a button or something like that. So not logging in again. And the problem was that, of course, on the user profile, in this case, like for instance, the athlete, because I said in this application, we will all be athletes. That's kind of cool, or I would like to think myself about that, although I'm surely, from my appearance, I'm far from it. But well, let's think about what we want to achieve. And the idea is that for an athlete, let's go to the athlete. Of course, I want to have the associated user with it. So what this means from a database perspective is that I want to have a foreign key on athlete to the corresponding user. And the same if I will have a trainer, I will have then a foreign key that corresponds to that specific user. So of course, if we think also about the entity framework here, what we would need to add is also a public int user ID. Although the user here, the identity user by default, if we navigate to it, is an identity user of string, and it will essentially have a GUID. Okay, I did press on, I guess F5. I'm not sure, but yeah, I guess on F5 I pressed. Sorry for that. Okay, good. So in this case, it would be a string that would point back to the user. So yeah, let's see how this will look like. So it's not an integer, but it will be a string instead. Okay, good. But on the other hand, on the user, I don't really need the collection back, because I will never want to access a certain or a list of user profiles from a user. If I want to switch between profiles, I will just well, be able to do that via the user directly, or sorry, via the athlete or trainer or something like that. So I won't actually need this. So, and this will also make this relationship not mandatory, I guess. Of course, in this case, we don't need this anymore, and we don't even need this constructor. So we could leave it like that. Now let's try to add a migration in this case to see exactly how, or yeah, how my database will actually look like. So where do I have it? Package manager console, add migration, add the user and athlete. Let's see if it works this time. I guess the lighting is a little bit too strong, maybe. Okay, I still have an error. I still have an error here. Okay, the entity type name requires a primary key to be defined. Okay, yeah, that's the problem. Because we have created this name as a record, and I assume do we really need an athlete type? Yeah, why not? That would be the regular user. I really want to keep this separation between the concept of user as a boundary for identity management and the concept of profile. If you think, for instance, about an application like Uber, it's exactly the same thing. So in Uber, you could be either a rider or you could be a driver, but you have the exact same user. So it's the same user behind, but you have two different profile types that you could choose from. And this is exactly the same concept that I would like to have here. Okay, why not adding only a bool prop user is athlete? Because we could have different user profile types. As said, we will have also trainers. We'll probably have, I don't know, maybe also admins or something like that. Or if we will have advertisers at a certain point that would create ads on our platform, then that would be a separate type of profile. And if I just add a bool, it's really not extensible at all. Good. Now the problem is that we have this record here. And I wanted, or I was assuming that entity framework would know to map this actually directly to the table, to the athlete table. and create columns for name.firstname, name.lastname. Actually, those two should not be mapped. I don't want to map this one. But I guess, shouldn't this be okay? No, it shouldn't be okay. Good. So I don't want to map this one, and I really don't want to map this one. We leave it like that. Now, of course, what we could do, and I guess even if, well, this contradicts this whole concept of value object, we'll also create an ID for that. But we'll also create an ID for that. But I don't really like this idea, but well, yeah, that's it. We'll actually use the ID, or we'll have it here only so that Entity Framework Core would be able to do the mappings. And well, that's one of the reasons that recently I prefer to use other ORMs, even Dapper, for instance. Because actually, my problem is that this is actually my core domain model, and I don't want theoretically, I wouldn't like that my core domain model would be influenced in any way by things that are outside of the domain model, like for instance the persistence layer and logic. But I guess that's a trade-off that we should make right now, because I want to get this working. But then we'll have the same problem also here. So let's in. Okay. May I consider using Fluent API for the mapping? Yeah, I like to use configuration classes and use Fluent assertions for that. And probably we'll do that at a certain point. But right now I just wanted to prove, or to look at the basic schema and then continue working through the domain model. I usually have always a folder configurations, and there in that folder I put all my configurations for Entity Framework Core. Okay, good. Then what we'll have here, profile location. Let's add also an ID here. I also never used records with Entity Framework Core, so it's really a first for me. So I'm not sure even if having the ID as an init-only property is okay for Entity Framework Core, but I guess we'll find it out soon enough. And what else do we have here for now? I guess for now we only have this one. Okay, good. Let's try to add the migration once again. It's still okay. Of course, yeah, that's unfortunately. Okay, so the migration is done right now. So let me check what we have added. So we have added a column int name ID in the table ASP.int users and type int. This is because we already had the identity user in the database, as I wanted to be able to log in the front end. That's the only thing we did in the front end. We just wanted to log in. But then we create a new table for name. That's what I have expected. But then let's see, it has an ID, a first name and a last name, which is correct. And then we have indexes here. Okay, of course, we didn't create the athlete at all. I guess this was the migration. Let's delete this migration. Because the athlete was not added, because let's go to the DB context. I need to add a DB set of it. Public. Let me see. This class is named wrong. Let's change the naming here. It should be without an S. Let's change it everywhere. So right now it should be okay. And now if I add the migration, it should actually do it. Okay. Hello. Thank you very much for commenting in Twitch, and I'm glad that you got to see me directly. Good. Let's see. Let's add this migration from new. Okay. What is the problem? No super constructor was found for entity type hate. But where do I have hate? I guess I have on athlete. I have hate, wait. Okay. And the problem is these are once again value objects, or I think about them as value objects. So well, first of all, private entity framework needs a default constructor. It can be private, but entity framework core needs it. So we'll provide that. Okay. Yeah, there was a time when I did some videos on domain-driven design. I still like domain-driven design very, very much. But for this type of applications that are fairly simple, I guess it really adds too much complexity. And in fact, what I do instead is in developing, I would say, following a regular entire architecture, I like to bring in some DDD concepts. Like for instance, I use these records, which is a new feature of C#9, and it's essentially modeling a value object. So for my value objects, I really use records in this case, which is a concept that I actually take from DDD. Good, but we have to go also to the other properties, and of course, we'll also need an ID for that. Public int ID get init. As I said, we'll actually never use this ID, and we'll never check for ID equality. So yeah, but I see right now the problem with these approaches, and probably will end up in configuring this differently, is that when I will check for equality between two hate objects, it will always try to also check for the ID. So probably we'll have to override that at a certain point and or configure this differently. Yeah. I'm still thinking about how to proceed here. But I guess for now I'll leave it like that. Okay, let's go for all the others and do exactly the same thing. So for name we have the ID, and I'm not sure why it happened that for this one, or probably I did get an error message also for this. Let's provide private name, provide a private constructor also for this one. For height, we have to do exactly the same things. Let's provide a private constructor. And let's provide an ID. So I have here this interesting comment on Twitch. Believe it or not, I'm the CTO of a one-year software agency in Spain. Started implementing some DDD patterns like 6 months ago. Okay, that's very cool. I'm really happy to hear that. Okay, sure. I guess here on Twitch, if you go to my channel, or you are also on Twitch, you can see, for instance, Twitter. You could just follow me on Twitter and write me a message there, and we could get in touch. And you're using TypeScript for your backend. It's a good choice, TypeScript instead of pure JavaScript. in I assume with Node.js. Is this correct? Okay. In the meantime, let's go here. Yeah, Node.js. I have done also some development on Node.js, so I'm not totally unaware of it. But yeah, it's more like side projects and things that I did with Node.js. So, and I guess the last time I wrote some Node.js was, I guess, 1 year ago. So I'm not very proficient in that. But Node.js is kind of cool, yeah. Good. Let's go also to okay. We see that we also need this ID here. Public key. And we have the same for distance. So let's do this to the private, but I want to have it private. I don't want anybody else to actually use my constructor here. So it's just for entity framework, and the ID also it's just public key get. Okay. Let's try to add the migration now. I still got error. No support constructor for profile location. Okay, seems we have forgotten to do this for this fellow here. Yeah, of course we need also a private constructor for it. Private profile location. That should do it. Let's try to do this once again. Oh my god, still errors. Profile settings. Okay, so it's the same thing here. Private. Okay, let's try again. Finally. Okay, so of course Entity Framework will create a table for all those value objects. That's it. But the idea is that each value object will actually refer to only one parent entity. So in this table we have, of course, ID, value, measurement, system. That's not very creatable. The same for profile location, the same for profile settings. So it's not really very complicated. But for profile settings, why do I have only one? Where do I have this? Because we have this string time zone. Oh, of course, those are not public. Oh my god, how could I do that? Okay, let's go back to the migration to see what other problems we have. For weight, now we have the value in the measurement system, which is okay. Then the create table at least. So we have the ID, profile photo URL, we have the location ID, we have the profile setting ID, we have the date of birth ID. Sorry, this is not an ID, that's just a datetime offset. We have gender, height ID, weight ID, and user ID, which is actually what we want. Let's see. Okay, we have here the foreign key to the ASP.NET users table, which is okay. and on delete referential action restrict. Okay. So don't perform the action if would. But theoretically, this means that when we delete an athlete, if it would create a problem with the constraints on the parent, which is user, then it wouldn't delete it. It would probably throw an error. Now, for referential actions, what we have here is cascade. I don't want to cascade. So if I delete an athlete, I don't want to also delete the user. So I really don't want to do that. Okay, then no action. Do nothing. Let's just ignore the constraint. I don't really want to ignore the constraint, but we can just use restrict, which should be okay. Good. Then we have another foreign key for height. We have a foreign key for profile location. We have a foreign key for profile settings, and we have a foreign key for weight ID, which is okay. And then all the indexes that were created. Now let's delete this migration because we have done some changes to one of the entities, and let's add the migration once again. So there's one more comment. Okay. Okay, sorry for that. So, I have noted you already, and I will get in touch with you on Twitter. Yeah, no problem. Good. So once again, yeah, we have everything here. Then we can run update. And here, since I already have a user, I probably will receive a warning that this update could result in some problems. Or, okay, cannot find the object profile setting because this does not exist or you do not have permissions. Okay. So I guess that's the problem with records. I guess that's the problem with records. So it's actually... Has anybody of you worked with records and Entity Framework Core? Because records seem like something to be very, very cool, but well, seems it's not very easy to work. Common timeout, altered profiles add, preferred measure and system. Failed, okay. So when it wanted to alter the table, okay. Let's look into the profile settings once again, because the ID is public. Let's see if we can just change the setter for the ID. That could be one thing. I will yeah, for that we'll have to delete this. And we'll have to add the migration once again. Let's change all the IDs here to have a setter instead. Okay, the user has a string, then wait. Although I could have left the migration because the changes that do, they don't actually have any effect on the migration. Okay. Let me check once again. So then profile location, it has set today the end set once again. Okay. So theoretically, I guess if we run an update database right now, yeah, in this case it's done. So the problem was that EF core couldn't set the foreign key constraints because this ID was an init only property. So we had to change this to set, but I really don't like that. So there's a lot of data retrieval stuff that is going actually into my domain model, and that's not something that I'm very, very proud of right now. Okay, let's just check the table, but I guess we should have everything there. So let's open the SQL Server Object Explorer. Databases, where is this? This one. And tables. So what tables do we have? So we have the, okay, these are a lot of tables that are actually coming from, actually, so it's ASP.NET users, ASP.NET user tokens. I did delete the migration. Haha, okay. That's why it actually didn't do anything. Yeah, sorry for that. Let's add the migration once again. But right now it says that it's actually an empty migration. That's actually very, very strange. So I'm not sure exactly what happens right now. Let me look into the migration history table. Okay, let's go on view data. So we have the initial migration and we have the update identity, which are those two. But I have deleted the other migration. It was not applied, it was not in the database. But in that case, what or why, if I go on add migration, it doesn't actually add it? That's strange, because it's actually a totally blank migration. Yes, I did run update database and nothing happened actually. And we see from the migration history table that the last migration that we added was actually not applied. Because if we go here on view data, we see that we only applied the initial one and the update identity, which is this one and this one. But this third one that we had previously was not even applied. And right now when I add a new migration, it just keeps it... you know what? Let's delete everything from here. Let's go to here. And we delete everything from here. And we'll also have to drop all these tables. And we'll start from scratch. Unfortunately, I'm not sure what exactly happened, so we have to force do everything. ASP.NET user roles. Hopefully I can delete this table. Okay. User tokens and ASP.NET users in it should be the last one. Update database. Okay. Good. So now we have the EF migration history table, which doesn't contain anything. So theoretically, what should happen right now? Let's add a new migration. But it's still empty, so I totally don't understand it. Or entity property. Yeah, these are all the plant validations that EF core does. Build target model. And here is this one, which is empty. I guess this one could be a problem. I guess I missed that class. So let's try it again. Okay, yeah, that's a total different thing here. Of course, now we have everything that that we had previously. So let's go with update database, and this should update the database accordingly. Done. So if we do a refresh here, yeah, we should see all the tables. So we have all the ASP.NET tables, and then we have athletes, which contains this column, basically a lot of foreign keys to user ID, weight, height, and things like that. But I just want to go, for instance, to height. I want to see if we have any constraint. So we actually don't have any constraints, which is actually not exactly what I wanted, because in this case, theoretically, what Entity Framework did is actually it's a one-to-many relationship, but I just wanted to have a one-to-one relationship. So I think I might need to go and do this via the configurations, but I guess I'll do this a little bit later. Okay. Profile location, the same thing. That of course has only one in the constraints. No constraint is created for that one. Okay. So yeah, theoretically, in this case, purely theoretically, one user could have several objects of type height and name and things like that. But in practice, we'll just update the existing one. So yeah, that shouldn't be a big problem right now. Good, so we have once again all the tables. That's kind of cool. Sorry for the small setback that we had. And so yeah, the lesson learned is that Entity Framework core doesn't play nice with records. That's something to note down, I guess. Okay, good. Let's go then one step further. And what I would like to do here is I would like to add a class for a workout. But the idea is that we could have a different type of workouts. I guess I should create a marker interface or an interface that would define all the things that all workouts should have in common. Then we'll create classes that will extend this, and yeah, let's create an abstraction for that. Add new class, let's choose interface. Okay, so right now what I can think about is that all workouts would have a public int id and also would have a public thing name or title. Let's call it title or name. Name maybe, I don't know. Okay, and then let's self also public thing description. Okay, let's have here public date time offset date created. So when the workout was created. Will we also be able to make updates to our workout? Probably. Public daytime offset date updated. Okay, a workout is always assigned to a user. So we have a user that performs the workout. So that's a very important thing. So that's why I will also have here, but that's actually an interface. Sorry for that. So we don't need to specify those public things. Sorry for that. It's actually not very often that I put properties in interfaces, but I still prefer interfaces than abstract classes for this type of inheritance, actually, because I like to think about what a workout is or what a profile is like more like as a contract, not necessarily as something that other derived types would have to inherit. Okay, and so we have a date created, we have a date updated. What else could we have in all type of workouts? Now workouts will be very different. We will have actually a lot of type of workouts. Like we'll have cycling workouts, running workouts, and things like that. And I would also like to save actually all or each workout type in a different table. So if you think this in terms of inheritance and concepts, like you would have, if you have an inheritance hierarchy, even though right now we can't talk about inheritance because we define this in an interface, but we have these two concepts like one table per hierarchy and one table per entity. And why I don't like the one table per hierarchy approach is that, well, we would have, or we would need to have a lot of discriminators, and we would have a huge table with a lot of columns. And for each workout, there will be a lot of columns that will be null because they theoretically belong to a different type of the hierarchy. That's why I would like to keep each type of workout in a separate table. And I think it would be also easier to perform statistics and analytics and things like that if we do it that way. So yeah, I prefer the approach to have one table per type. Okay, so this being said, once again, so what do we have in common for all workouts? We have an ID, we have a name, we have a description, date created, date updated. Okay. I guess that's pretty much it. If we find other things that we would like to have on a workout, and probably we'll also define some methods here, but probably they will evolve when we start working on them. And maybe when we try to implement also the UI, we'll see better exactly what we need. So let's create a new class in this case. Okay, so there are actually two types of workouts that I'm performing, not daily. So I walk a lot and I do ride a bicycle, so cycling. Let's start with cycling, which would be a class public, and it would be an I workout. I'm thinking about, should I rename this class to cycling workout? I don't really want to add this word workout at the end of each one. It's okay, it does implement it this way. I hate it. I hate this. So what I will do instead is I will go to I workout and just copy and paste them and just add a public keyword, and we should be good to go. Okay, so cycling. But I guess, let's add also a folder here because we'll have a lot of workouts. And let's put them all in this folder here. Okay. And it would be models workouts. Let's change the namespace. And yeah, that should be it. Good. So now I implement this one. And I need to make all them public. Public, what's wrong with you? Okay. One also. Good, and now we have implemented the interface for that. Now, okay, let's think about what we actually have for a cycling workout. I'm thinking right now. I guess we'll use a lot of interfaces here, because different type of workouts will have different type of functionalities or features to them. Like for certain workouts, like for I don't know, cycling, walking, running, you could be able to do different stuff based on distances. But for other type of workouts, like I don't know, if you do, I don't know, weightlifting or things like that, those workouts, they don't have a functionality that is distance related because they lack this concept of distance. That's why I guess we'll have to create different type of interfaces for different type of features that actually each workout would have. That's actually one approach that if you look at the .NET types, you will see that it's exactly the same thing. Like for instance, if we go on string, we see here all the functionalities that a string has based on the interfaces that it has. And we see that, well, it's an IEnumerable, it's an IClonable, it's an IComparable, so you can compare strings. It's convertible, and you can also verify strings for equality. So we'll have something similar to that probably. Of course, not with exactly the same concept. Now, okay, so cycling is actually a distance workout. Okay, so let's add a new interface. Let's add here also a subfolder, workout. Directions. And let's add here an interface. Good. Now, how should we name this? Naming is a very, very awful thing for me sometimes. Just 1 second. So how should we name this? How should we name this? Distance workout. I think about the namings we have like enumerable, clonable, distanceable. No, that wouldn't work. We'll change the namings later if we need. Let's call this distance workout public interface. Now this workout would have a property of type distance. Of course, this is not correct because we have this this distance class record actually. So yeah, that would be this one. So we'll have the concept of distance. And in distance right now we have here a value and we have a measurement type. Sorry, a system. So if it's metric or if it is imperial. Now probably also I guess the way that that we'll support it for now, it would be the distance will be measured, I guess, in kilometers by default. But probably we'll add some features to this distance. Maybe, I don't know, to get the value in kilometers, for instance, and or in miles, and calculate it also in subdivisions. So we'll see that probably a little bit later. So right now we have here a distance workout, which contains this one. Now I'm thinking about what behavior according to distance could the workout have, and right now I guess I don't have a very clear idea. But yeah, let's implement everything when we come to need it, so that we won't face the problem with the Yagni principle. You ain't gonna need it. So for now we need a distance, and we have this one. So let's go back to the workout, the cycling workout. And let's make it a distance workout. Okay, and this means that we'll have to implement that property public distance. Let's add using. Okay, good. Now for this one, we also need the duration, and the duration will be in minutes. Public int duration. I guess duration will be something that all workouts will have, because I guess each workout, no matter what type of workout, will have a duration, even if it's walking, running, climbing, hiking, boxing, kickboxing, football playing, basketball, whatever. It's each workout will have a duration. So I guess that should be in the contract for that. So let's go to the. So it's actually for all of them, so it would be int and we want to have it in minutes because it's actually easier afterwards to calculate different type of statistics, like how many calories you have burned and things similar to that. And that's why we want to have it in minutes. And this doesn't really mean that in the front end the user will have to provide it in minutes. User could simply, I don't know, we could have a form with a value for hours, with a value for minutes, and a value for seconds, and we can then calculate basically based on what user chooses how many minutes we have in the specific workout. And the same thing is when we actually want to throw a duration on the front end, we can just calculate based on the minutes. Okay, it was 1 hour and 20 minutes, for instance. So that would be something very easy to do. Okay, let's go further. What else do we have on the cycling work on? We have the distance. We have here, we could have here, for instance, public I was thinking about the speed, and speed is actually then another type that we should define in common. And we will probably also have to do conversions between metric and the imperial system. But for now, let's keep it like that. So let's have here speed. Let's make it also record. Although, sincerely spoken, if we need to add an ID to our records, then that's actually not a record anymore. So yeah, it doesn't really help much. So let's go back to classes. So for speed, we'll have public int ID. Get that. It's similar for height and value. Public. It would be also int. Actually, it would be double because we could the speed is usually expressed in doubles of value. It's set, and we'll have here a public measurement system. We have to provide a measurement system for that. And we'll do it similarly to what we did earlier. We'll provide a constructor, a public constructor. Yeah, I know I could use tabs. And we'll provide here, I want a double value and a measurement system. And we'll just assign them. Okay, measurement system equals, so that should be it. Okay, and we'll have also here to do the conversions, but I'm not sure exactly how to do the conversions. So I guess we have an interface for that. I'm measurement convertible. Oh yeah, let's implement that. Speed implements I measurement convertible of type speed. Okay, then we'll have to also implement the interfaces. Okay. Good. Let's just well, okay, let's keep it here. Let's do a Google search for that. Formula convert we want to convert kilometers per hours into miles per hours. Okay, so the speed in miles per hour is equal to the speed of kilometers per hour divided by, okay, let's check this out. So 1 kilometer, okay, this is the basic rule for that. So 1k, okay, is equal to this one. So So in this case, if I want miles per hour, it's kilometers per hour divided by this. And if I want to do it the other way around, what's actually here? And miles per hour. Yeah, but I'm not sure exactly. Okay, I have this formula, but I want to see exactly how can I convert also the other way around. And there was a table somewhere, but I don't remember where. I just want to see how it is calculated. Don't want a converter. I don't know, on Quora maybe we'll find an answer to that. I'm not sure about that. So, good, there's a lot of ways to do this, but they're pretty much the same. Conceptually, you need a direct conversion between okay and US measures, since both are okay. But I don't want inches here. Okay. So it goes way to the millimeter. Okay, so this is from kilometers to miles. Okay. Take the speed and halve it, and add back the numbers. Okay, that's complicated. Oh my god, it's very... Oh my god, both are speed unit. Okay. That also doesn't really help very much. So if you have an idea about the conversions, that would be actually great. So the definition, do we have here something? Okay. Now here it's once again it just tells us, okay, how to convert. Okay, 1 kilometer per hour. Okay. And 1 mile per hour is okay, like this one. Okay, so in this case, if we have 15, okay, then we have to actually multiply by this one, by the mile, and this would be this value. Okay, so if we want to do the other way around, then we'll have, I guess, to... So if we have 15 miles per hour, 15 miles per hour, then we will have just to multiply by this one. Yeah, I guess that's it. Okay, so let's try to do that. So let me move this kind of like back. Good. So here I want to convert from imperial to metric. So right now, what I will do, similarly to what I have done also for the other. So if measurement system is already metric, I actually don't have to do a conversion, so I just return this. But else, so once again from imperial, so this would be that I want to convert from mile per hour. to I want to convert from a mile per hour to a kilometer per hour. So in that case, I will have to actually take this value here. So it would be return new speed, and here we'll provide the value times 0.6 and so on, and then measurement system dot imperial. No, actually we want metric, sorry. But in this case, it's not this value, it's the other one. Okay, and then convert from, let's just copy this. And let's put it here. Now we just have to change things. So if it is imperial, then we just return that. So in this case, it's value times, and in that case, we should use this one. And we should actually be good to go. Okay, so we have the conversion from a kilometer per hour to miles per hour here in this speed. So yeah, we can now go one step further, I guess, and go back to our workout. Where is it? Where do we have it? Workout cycling. Okay, int duration. So we have here a public speed I guess it should be this way. Okay. What else would we have? Because the idea is that speed, we have different type of speed. We have average speed for the workout, public speed, max speed. Okay, why did it do it like that? Okay, so we have duration, we have average speed, we have maximum speed, we have the distance. What else do we want to know for a cycling workout? I guess for now it should do it. We look into it, then maybe when we need new features, we'll simply add them. Guys, I need to take a short break, and I'll be back in 5 minutes, I promise you, and we'll continue to work on our workouts, and I hope to finalize this very basic domain model to be able to do a migration, and then maybe to think about, okay, how we'll implement things in the front end. So please stay tuned. I'll be just back in 5 minutes. Okay guys, I'm back. And yeah, during this break I guess I had a few ideas about how we should proceed next. And I guess I would like to implement all the layers for this type of idea of workouts and things like that. So we'll implement also repositories and services. And I'll come back to this and explain why I think that in this application we need to have both repositories but also services, I guess. So, but before we go to that, I was thinking about this idea of cycling workout. What we also have here, we could also cycle uphill and downhill. And usually in all apps that track your bike rides, you also get information about the elevation gain and elevation loss. And I guess we can express this in height, because we have this concept of height. So in this case, we'll see here public, let's say it height, elevation gain, get set, and we'll have here public height, elevation loss. Okay. And maybe we'll have something like public height, total elevation. How can we offset? Maybe, I don't know if that name is correct, but it's not really an offset because we just want to know. Let's call it total elevation, which will be actually a sum of these two here. And actually this one I want it be not mapped, so let's add the not mapped attribute, because I want to calculate this. Actually I don't want to be able to set this. So what we'll do in this case, we'll just move out setter, and we'll have only the get, and in the get we'll have something like return get total elevation. And of course we'll have to implement this method privately. Of course, private, it would return a height, and it would be a total get total elevation, get I guess we can just take these two height objects and add the values and return a third one which has the new value but the same measurement system. Okay, if we have, I don't think I want to implement here right now a lot of use cases, like what if this one will have one measurement system and this one will have a different measurement system. For this very simple proof of concept, let's assume that they both have the same one. So we'll simply return new height, and we'll have to provide elevation gain dot plus elevation loss, and the measurement system actually we can just take the measurement system from either of them. Elevation gain dot measurement system. Okay, but here we have to add the values. And that should do it, I guess. Okay, get total elevation. I forgot. Why? I guess. Yes, I guess I have a typo. Correct. And right now that should work. And of course we need a semicolon here. and that should do it. So this one is not something that we want to map. This is something that we just simply calculate based on two values that we already have, and we also don't want to be able to set this separately. So yeah, that's so for cycling workout, I guess we have here then the idea of speed, we have the idea of distance, we have here the idea of elevation, and I guess for the elevation we would need another interface, eye elevation workout, or how did we call them? Eye distance workout. Yeah, let's add new class, interface. And I guess when we'll implement services, we'll see exactly why we actually need this type of interfaces. Eye elevation workout. The reason why we need here this interface is that we will have also, for instance, workouts like hiking, where you will also have an elevation gain and elevation loss and things like that. So yeah, we have this an eye elevation workout. Let's make it also public. So these two, where do I have that? Where cycling, this one, and it would be, I guess, these three. But of course, from the interface, we'll remove that. My elevation workout, public height. Let's add the using for that. We don't need this not mapped, and here we just want to have a getter for that one, and I guess that should do it. Let's go back to our cycling, and let's also say it implements the eye elevation workout, and I guess it should be okay because I have implemented this. Correct. I guess we will also have a speed workout, because speed is something that you could have also for walking, for running, for skiing, for actually there are a lot of type of workouts that you could have, and that would involve speeds, and then having an average speed and the max speed for the workout might be something important. Okay, so let's just copy those here, and let's create a new abstraction for that, and we'll call that I. So speed workout. Of course, it's an interface, and we want to have these properties here. So we have speed, we need to add usings, and that should be okay. So let's go back to cycling, and also say that it implements eye speed workout. Okay, so I guess I'm fine with that. And if you have ideas about other things that the cycling workout would need as an information, then please just let me know. But I guess for now we are pretty much covered. Now let's maybe add another type of workout that we have at least two. And let's add the new class. Let's add a workout for walking. Public class. Okay. So this one would implement eye workout. Now, regular walking is something that I guess we wouldn't really need to calculate the distance, because if you walk uphill, then that would be actually a hiking workout. The walking, we assume that, well, it's fairly plain, I guess. So in this case, okay, the interface is not implemented. I don't want to implement them like this. Yeah, or maybe yes, we just will delete everything that we need But if you walk, you would have also, it would be an I distance workout. But why doesn't it see this interface? Workout abstractions, okay. Let's also implement this. Then this would also be an I mean, when walking, speed is not something that you really calculate. It's more the number of steps and the total kilometers that you... So you don't actually calculate speed usually for those type of workouts. But, so you don't calculate speed, you don't calculate elevation, usually, because if you have elevation, that would be already hiking. And I guess these are only two interfaces that we'll implement here. So it would be I workout. Good. Okay, let's start to delete here a lot of stuff. Okay. Okay, not like that, not like that. Good. Let's also delete this one and this one. Okay, and here we need to delete this one. We need to add a semicolon, and we need to delete this one. Okay, a lot of deletes that we have to do here, but well, that's it. It's still faster than writing all the properties one after the other. Okay. And then what we'll have for a walking workout, usually all the apps that track your walking would be int steps. How many steps you covered. And yeah, that would actually be it for a walking workout, I guess. So nothing really more to it than that. So that should be okay, I guess. Good. So we have right now two type of workouts, and yeah, I guess let's keep it like this for now. Okay, and okay. Good. So we have these two workouts. Let's add them to the DB context. Public DB set of cycling. Okay, we need a new using here, of course. Here as a DB set, we can also name them workouts, because we still have to pluralize the name. Public DB set of walking. Good. So we have this. Now, as said, I guess I would like to go through all the layers and to create actually repositories and services. And we'll also explain why we actually need, or why I think that we will need both repositories and both services. Now, the difference between a repository and a service is actually that for a repository, or repositories are actually for data retrieval. Now, I know So I noticed that entity framework DB context already implements this concept of repository pattern and unit of work. But what I really like to do is when I have, I would say, some more specific data retrieval logic, then I would like to implement my own repositories. And one reason for that is that, of course, repositories are exposed through an interface. And the reason is, if I at a certain point want to change my my database, actually, as long as my repository interface remains the same, actually, if I have to switch the database and use something else instead of the entity framework core DB context, now all the consumers of my repositories, they wouldn't have to update anything. So all the changes that I would have to do, or that I would have to do, would be only in the repository class, no matter, for instance, if or as long as the repository sticks to the interface, and it should of course stick to the interface. So I would like to implement also my own repositories because of this. And on the other hand, what we will need is also we'll need services, because we will need, or probably will have, different type of services. For instance, what I can see is that we will have, for instance, probably a cycling service, which will actually perform different operations on cycling workouts. Like, I don't know, calculate the total numbers of kilometers covered, or during a specific time frame, or total number of elevation gains between, I don't know, workouts, cycling workouts on a certain period, and things like that. But on the other hand, I might want to also have, for instance, a distance service. And the distance service could be used, for instance, in our application to retrieve some more extensive analytics. Like, for instance, how many kilometers did I cover during 1 year? No matter if through walking or through cycling, as long as I have a collection of workouts that implemented that distance interface, I can have a distance service that would perform different aggregations and calculations on different type of workouts that implement that concept of distance. And that's the reason why I would like to have both repositories, but also services in my application. So in this case, let's get started with that. Now, as outlined actually, I guess, in the first video of this series, so if you go to episode number 1, I guess you'll see that, is that, well, of course, what we want to do is I want to define the interfaces in the core layer, so in the domain model layer, but the implementation of those interfaces would actually be in the infrastructure layer. And actually, this is very important for this inversion of control principle, because, for instance, if you implement or if you define some interfaces that are specific for the infrastructure layer, then you should implement them in a layer that is actually above. So we always keep, when you have this layered architecture, one of the things that I found very useful is that we should always be very, very careful and define interfaces in one layer, but implement them in a different layer, for instance. So that would be a very, from my experience, a very important guideline. So let's then, in this case, try to first go with the repository interfaces, and then we'll implement those interfaces in our repositories in the infrastructure part. So we have here in the core, we have abstractions, we have workout abstractions. So let's create here a new folder, and we'll call this repositories. Okay. And right now, okay, what type of repositories would I need? I would need actually a repository, I guess, for all of my DB sets. So I have an user repository. Okay, so I have a user repository. Of course, that would be an interface. Interface here. Now, for the user, there's actually, for the whole identity management stuff that we have, actually we have a service which is, I guess it's the sign-in manager or something like that, that we could use for updating stuff that is related to identity management. So if I go to my user, actually what I could do here is, so user creation will be handled by the sign-in manager when you register. User deletion is something that we might find useful at a certain point, but right now the only thing that I think for a user that we could implement in a repository is update the user. And what I would like to do is update the user. I guess I would like to update user also as a whole. Okay. Yeah, so let's go for an update. So here what we would return is a task. Although what I like, or I heard that this is probably not a very good approach, but once again, based on my experience and on the applications, once again the production applications that I worked on, I found it useful that actually my services, the repository is not really a service, but the services should actually not return directly, I would say, a type like a user, but it would always return a service result. And the reason why I like to do this is that in the services we would catch all the exceptions that we get along the way. We could even add them to a list in the service result, and then the consumers of those service, like in our case it will be the interface, our Blazor server, can look, for instance, through the errors that the service generated and decide exactly what it actually wants to display or what it actually wants to do. So I like to throw errors everywhere, but in the services I would like to catch them. I would like to put them at one place. Of course, also logging would be important, and then the consumers of the service should always be or have this choice at least to look into the service result, and based on the information that the service result contains, they should be able to decide exactly what they want to do. So once again, this however doesn't apply for the user repository, because this is a repository. Repositories will actually be used in services, so we'll expose the repositories through services. So the consumers will actually use services for this. So yeah, let's look a little bit into this one. So in the iUser repository, I want to have I would have a task that would return a user, and this would be update user async, and this one should, of course we need the using, should take in a user, updated user, and this user should be the updated version of the user that we actually want to update. So actually I guess that would, for now, this would be the only method that we will implement in our repository. Let's then also go, we need a repository for our athletes. Where do we have here athletes? Yeah, here we have a lot of details actually. Maybe we'll just we'll give options to update the location, update the profile settings separately, and I don't know, update the basic user information, update height and weight. Yeah, let's, but you know what? Yeah, I would like to create a repository for each profile type. But then for the service, I will have a user profile service, that will kind of perform different actions on different type of profiles. Because here, for instance, we could handle connection requests from one athlete to a trainer, for instance, or from one trainer to an athlete, and we would have then a user profile service and everything like these interactions that may exist between different user types or user profiles will have handled in the in the service. But for now, let's go here and add a new repository. Let's choose here interface and let's name it athlete repository. Now, the idea is that here in this repository, we would actually also need to create a user profile or an athlete in this case. So we'll have first, it would be a task and it will return, it will return an athlete. Probably the created athlete. And here we'll have athlete create athlete async, and we'll take in an athlete that needs to be created. Then for an athlete, we would have once again a task of, and why I said that I like to use repositories is that because I want to have a slightly more complex data persistence system. For instance, what I would have here is I would like for an athlete, for instance, to update profile settings async. And in this case, what we would need here is an ID for athlete, ID, and we would need a profile settings. So the settings that actually need to be updated. Okay, so in this case, good. The same way, if we go here, we want to be able to profile location. If we want to do an update at the profile location, we should have a separate method in the repository for that, and it would also return a task of athlete. But in this case, it would be update profile location async, and we'll need here an int athlete ID and the updated profile location. Okay, and then let's take another look at our athlete and see what else do we have here. So we have this date of birth, profile photo URL, height, weight, gender. The user, this is not something that we'll be able to update. We'll establish the connection once the athlete is created, and we shouldn't be able to edit this. So we need then another method to update I don't know, this type, like profile photo URL, gender, height, and weight. Let's call this update basic info. Task athlete update basic info async. Here once again what we need is the athlete ID. And what is actually that basic info? Once again, URI profile photo, okay. URI profile photo, what we have here, we have a date and offset date of birth if we want to update that one. Okay, let's call it like this, date of birth. Okay, and let's go here down one line. Also, let's make this bigger. Okay, then what else do we actually need here? We need height and weight. So it would be height, height, and weight. Weight. I guess we need a new using for that. Okay. And what else do we have? Gender. We have gender that we can update. Here, gender. That's also in a separate folder, I guess. Good. So, what we could do here is, so this is actually an enum and it has actually these two here. So we see that the athlete ID should be actually required. This could be actually have a default of null. This could also, but this is actually non-nullable. In this case, we could have here a date time offset, but we can cast it to a default in this case, or something like that. Okay. And probably in the logic for this one, we'll check for this default and we'll keep the old value, I guess, if it's the default one. For instance, what I want to do here is that for when consumers want to do an update, if they just want to update the profile photo, they could just specify this one, but for all those others, they would specify default value or null. So yeah, the same goes for height. Now the default equals null, and in that case we won't do any update to it. And then weight, the same thing. And for the gender, I guess that's also an enum, so I guess that can't be null. But what's the default for the gender? That's actually strange because in this case we can't really infer from that, because the default value would probably be 0, but 0 would correspond to this one. So yeah, that's not something that we could actually assume. So I guess what we'll have to do is move this parameter actually right after, or right before all the others that have also default values. And that should be like this. So yes, that would be the repository for update the basic information. And now we have the create athlete. We have a different updates method for the athlete. And then what else do we need? Of course, we would need to delete an athlete. Sorry, just one second, because I'm not sure if my stream on Twitch is still working, but I guess it should be. And on YouTube everything is okay. I guess everything's okay on YouTube. Good. So let's also create in this repository a task. I'm not sure, do I want to return a deleted athlete, or Yeah, let's return it so that the consumer knows which athlete exactly was deleted. Delete athlete async, and here the only thing that we would need is int athlete ID. Okay, and then I guess basically we need to implement a repository for each DB set. We have implemented a repository for this one, a repository for this one, and then we have to implement repositories, or sorry, to define repository interfaces for this type of workouts. So let's go back here to the repositories and let's start with add a new class and choose interface, cycling repository. Good. Now, if we go here, what operations can we have here? So first of all, we need to create a cycling workout. Good. So let's go to the repository. Be task of cycling. Okay. Create workout async. If it is the iCycling repository, I guess it's fairly clear what type of workout we actually want to create. And here we need a cycling workout, and that should be it. Now, if we want to do an update here we have a lot of different properties, but they are actually not. So we could even update them individually. So what I would do here is I will create only one method, I guess, for this repository, for this update. So it would be a task once again of cycling update workout async. Let's have the updated workout. I will have a task of once again cycling delete workout async, and here we just want the ID int workout ID. We have a create, get, and update. Now, when we want to get a cycling workout or a collection of cycling workouts, you know what I just realized? I realized that actually for each workout we would also need the user to which it belongs. So in this case we'll have to go to the iWorkout class, iAthlete cycling user repository. Where is it? iWorkout here. So we'll have here int user ID, and we'll have user not user profile, just a regular user. That's actually something that each of the workouts will actually need. So let's copy this and go to our cycling workout, and let's add those. Of course, they should be also public. They should also be public. But actually, right now, actually we don't need user. Because as I said, the user in this application will be a boundary for identity management. But the workout would be associated to an athlete profile. So you only as an athlete you can perform workouts, or you can track your workouts. So in this case we have to make a slight change here. Sorry for that. Where is the interface? So it's iWorkout. So it's not the user ID, and however the user ID wouldn't be an int because the identity user has a default GUID, but instead it would be an int athlete ID, and we need an athlete. So who performed actually this workout? That's actually what we need. Okay, so let's go to the workouts, and instead of those, let's add those. Public int athlete ID and public athlete. Okay. And the same, let's just copy this one in this case, should be also for the walking. And now the interface should be implemented and everything should be fine. Good. So why I came to this conclusion is because if we want here to know the idea is that for this repository, depending on the needs of the application, because we could have, I don't know, something like an admin dashboard where we will have, I don't know, statistics about the workouts that performed by different users and things like that. We would have, for instance, if I go here on the iUser repository, not user, iAthlete, iCycling repository, we would have something like, for instance, task of what should we return? For instance, collection of cycling. And that would be get workouts. What do we have here on? We have here this date created. We can have, for instance, get workouts for time interval, and here, for instance, we would have a date time offset start time, and we'll have a date time offset end time. And I guess you get the idea. So we can have this more generic that gets, I don't know, cycling workouts that actually don't take into consideration a certain user. But the same way, we could, for instance, have a task of collection of cycling. And here it would be get workout. If we want to get one specific workout, so as we have an iCollection here, get user workouts. And here the only thing that we would have to specify would be an int athlete ID. In this case, let's not use user, but then also this should have async in the name. Okay, and the same way, for instance, we could have, for instance, I don't know, task of collection of cycling. And here we would have get at data workouts for time interval. In this case, we would have an int athlete ID. We'll have a date time. Let's go on a different line. We'll have a date time offset, which is the start time, and date time offset, which is the end time. Okay, so I guess we will figure out exactly what other methods will we need, but I hope that by now the idea is clear why we need actually repositories, because we will have more or slightly more complicated logic for data retrieval and data writing. Okay, so I'm thinking about when we will want to add a new workout in our application. We have this create workout async. Also, this needs async in the naming. So we have the create, we have the ability to update it, we have the ability to delete a workout. And on my user dashboard or on my athlete dashboard, for instance, I want to see my cycling workouts for a time period, for instance. And in this case, I can see all my workouts, but I can also see them based on a certain time period. And of course, actually, what we could do later is maybe if we see that we need it, we can actually extract maybe all this logic in a specification. I like to use actually specifications in order to retrieve data, because in this specification you can just provide exactly what are exactly the specs of that user of that object that you would actually want to retrieve from the database. And you can just have only one method, for instance, like, okay, here's the specification, and based on the specification, then that method would return objects that actually meet the criteria that you specify in that specification. And I know that the specification pattern is usually used more in conjunction with validation or with creational patterns, but I really and totally like to use the specification pattern for data retrieval logic, because you simplify your code a lot. For instance, instead of having these 3 different methods, we would actually have only one that takes in an I specification of cycling workout, and based on the specification, then I would retrieve the data in the repository. But I guess we'll come to that once we want to implement this stuff. Okay, so we are able to get workouts for an athlete and for a time interval, and actually it would be the same. But right now, I guess if I want to write a repository for walking, I would probably have all these methods. So I could do, let's try to do it like this one. Interface segregation is called this in the solid principles. I workout repository. Let's make this an interface, public interface, and I would like to be this an I workout repository, which would be a T. And since we use actually a lot of interfaces on our workouts, we could also say here that where a T implements I workout. We'll see later if this this really brings us further, but right now what we could do here is go here in this I cycling repository and create workout async, update workout async, delete workout async, actually all of these methods can be part of that generic. Okay. I workout repository. Now the only thing here is this would be generic. That would be a T. That would also be a T. That would also be a T. And once again, T. Workout ID. Good. Then I collection of T would be this one. Then this one would once again be a T. So those methods would actually be exactly the same for all type of workouts. And then if I go in the iCycling repository, I would say that it implements an I workout repository of cycling. And here in this interface, I would then specify only repository methods that are actually specific for my cycling workout. And if I go to cycling right now, I'm not sure exactly what I could have here. But let's keep this extensible. And I'll still have this iCycling repository that implements iWorkout repository. And if we need to add some data persistence logic that is specific only for cycling workouts, then we will add them here in this repository. But this actually has also simplified our work here, because what we can do here is add a class. Okay, we'll add a new interface, of course, and we'll call this walking repository, and we'll say that this interface actually implements workout repository of walking. Okay, and yeah, that's actually it. So right now, if we have an interface, if we want to implement those in the infrastructure layer, we will implement the iCycling repository, which in turn will actually oblige us to implement this interface that already contains this method that are specific for a workout. And as you can see, for the iUser repository, we don't have those, or for the iAthlete repositories. And we have here specific methods that are all only for athletes. And yeah, I guess that should be it, because it's already late. It's more than 2 hours. And yeah, I guess we'll have to continue, and probably tomorrow. So if you have time, please join me tomorrow around the same time. And we'll continue to implement these repositories. Then we'll implement some services. And once the repositories and the services are implemented, we can move to the next step and look a little bit also at the UI. I'm not sure if we'll be able to really get to the UI tomorrow, because we still have plenty of work to do, like implementing the repositories, implementing different services. Probably while coding, we will see that, okay, maybe we need to refactor some of the things. And I guess that for tomorrow we'll be pretty much covered with this backend part that we still want to implement. But then I guess it's fairly straightforward, and we'll go over to implement also some basic functionalities on the UI. So yeah, this being said, thank you very much for watching, for being here. Thank you very much for commenting, for being active in the chat. I'm really glad you joined me, and I can't wait to also see you tomorrow. But until then, I wish you the very best and take care of you. Bye.